Okay, welcome to this lesson on adding and subtracting monomials. If you're wondering why my voice sounds a little bit hollow, well, my wireless microphone isn't working, so hopefully you can hear me just fine. If not, turn that volume up a little bit so that you can hear me nice and clearly. Okay, to be talking about adding and subtracting monomials, we have to have a couple things understood. Number one is what are like terms. So when we're thinking about algebra tiles, we know that like terms are really just like tiles, tiles that are the same. And then of course we can put tiles that are the same together. Zero principle, going back to like terms, well, if we're talking about pencil and paper, well, we're talking about terms that have the exact same variable part. So now moving on to the zero principle, when we're talking about tiles, we're referring to the idea that tiles that are the same but opposite, so like a positive and a negative tile, cancel each other out as long as they're the same kind of tile. We have to have like terms and zero principle well understood in order to truly appreciate and figure out what's going on here with adding and subtracting monomials. Well, let's get into a couple of examples. Actually, we'll look at one example and we'll show you how algebra tiles can prove the answer, but then also how we can use pencil and paper using the ideas of like terms and zero principle to do it using pencil paper. Here we go. Alright, let's go with 2a, 2x plus 3y minus x plus 2y. So, using algebra tiles, here we go. Well, 2x, we know looks like this. 3y looks like this. Oops. Negative x looks like this. And finally, 2y, here we go. Alright, so the idea behind the zero principle with tiles is, hey, let's put the tiles that are the same side by side and see if anything cancels out. So we're just doing some quick rearrangement. Here we go. We'll move these over here, we'll slide this here, bring them on back. And it's quick to see that, hey, we got zero principle here and here, right? Okay, we can totally use zero principle. Let's get rid of these tiles using zero principle. And it's pretty clear that the answer now is x plus, well, let's see here, 1, 2, 3, 4, 5y. So x plus 5y is the simplified expression. Now we're going to use pencil and paper to show the same thing. So again, the question was 2x plus, 3y minus x plus 2y. Okay, so using pencil and paper, we're going to use the same ideas as we were just using for the tiles. So, remember when we took the tiles and we were rearranging them? Well, we're going to do the same thing, except we're going to rearrange the terms. And remember when we took the tiles and when we rearranged them, we were putting tiles that were the same side by side? Well, now we're going to take the terms and put the like terms side by side. So, 2x, we're going to start with that. And now we ask ourselves, are there any like terms that go with 2x? Well, remember, like terms have the exact same variable part. So hopefully you see that, hey, negative x is a like term. Notice the next thing I write is negative x. I didn't put this plus sign that's right here. Okay, it doesn't belong there. And so I'm not going to put it. I'm simply going to put negative x. So a very important thing to say right now is that the sign in front of the term belongs to that term. Very, very important. Continuing on, well, there's no other like terms, so positive 3y comes next. And then finally, is there any like terms? Of course there is. Positive 2y goes with that. Well, remember that the answer was x plus 5y. Well, looking at pencil and paper, it's like, well, it appears the only thing that has to happen is that the coefficients, you actually do just addition and subtraction. So 2x minus x is x. And the way to explain that, don't forget this, negative x is like negative 1x. Basically, we're just saying 2 minus 1. And then over here, when we're looking at 3y plus 2y, well, that's just 3 plus 2 is 5. The variable part stays exactly the same, and we end up with x plus 5y. Interesting.